Hello everyone, I'm Juan Lu from Purdue. Today I'll present our work on understanding how humans rely on machine learning models when performance feedback is limited. Recently, many decision aids that are based on machine learning models have been developed to help people make better decisions. And it is shown that people tend to rely on them more when the model's performance is higher. However, in reality, there are cases that the model's performance information is not readily available. In these cases, how do people decide whether to rely on the model or not? Interestingly, when psychologists look into a similar question in the context of human advice taking, they find that when people need to decide on whether to rely on a human advisor without the knowledge on the quality of their advice, they tend to rely on the advisor more if their advice agrees with the person's own belief, especially when the person has high confidence in her own belief. Naturally, we wonder whether humans decide their reliance on machine models in a similar way when performance feedback about the model is limited. More specifically, we are interested in three research questions. First, does high-confidence human model agreement affect people's reliance on the model when there is no performance information about the model? If so, does such agreement still affect reliance after people have obtained some information about the model's performance? Finally, in reality, people can agree or disagree with the machine model, both on tasks that they are confident and on tasks that they are not confident. How does people's own confidence in cases that they agree or disagree with the model change their reliance on the model? To answer these questions, we conduct a few human subject experiments. In our experiment, we ask subjects to review the information of speed dating participants, and then predict whether the participant would want to see the dating partner again. Subjects need to first make their own independent prediction, and then review the machine model's prediction. After that, subjects will make their final predictions. To enable our experimental design, we first conduct a pilot study. We ask subjects to complete a large set of speed dating prediction tasks and report their prediction confidence in each task to us. Based on the data we collect, we categorize prediction tasks into 4 types, depending on whether the majority's prediction is correct or incorrect, as well as whether people's average confidence in the prediction is high or low. Our first experiment is designed to answer our first research question. In total, we include 30 prediction tasks in our experiment, divided into 2 phases. Phase 1 consists of 20 tasks that are previously categorized as people having high confidence in. We then create 3 treatments by changing the frequency for the machine model to agree with the majority's independent prediction, from 40% to 70% to 100%, but we keep the model's accuracy at the same level. In addition, Phase 2 is designed to measure subjects' reliance on the model. To maximize the possible effects, we use 10 low-confidence tasks in Phase 2. And all models' predictions are the same on these tasks. Subjects' reliance on the model is measured through how frequently the subject's final prediction is the same as the model's prediction. Our results from Experiment 1 indeed show that as the level of agreement between the model and subjects in Phase 1 increases, subjects self-report that they find the model to be more accurate, more reliable, and more understandable. As a result, subjects also rely on the model more in Phase 2. In other words, people use their level of agreement with the model on high-confidence tasks as a heuristic to adjust their reliance on the model. However, such heuristic can also bring risks. For example, as we can see, people's reliance on the model not only increases with agreement when the model is correct, but also when it is incorrect. This implies that using this heuristic, people may overgeneralize their perceived model performance without carefully differentiating correct and incorrect predictions. The designs of our experiment 2 and 3 are similar to that of experiment 1. The key difference is that in experiment 2, subjects would receive some feedback about the model's accuracy in Phase 1 between the 2 phases. In experiment 3, we include both high-confidence tasks and low-confidence tasks in Phase 1. So we can control when subjects agree or disagree with the model, whether they are confident about their own predictions or not. Through these 2 experiments, we find that after people obtain some performance information about the model, the level of high-confidence human model agreement does not affect reliance anymore. Also, we find that people's confidence in their agreement with the model interacts with people's confidence in their disagreement with the model, influencing their reliance on the model. That's all for our project. Thank you, and I'm happy to take questions.